Hey there, I'm Josh Erkman. I'm here and we're going to talk about Engineering Systems, a book by MIT. And we're going to be talking about the third chapter today, which they've titled Rethinking About Systems. So, one major concept that we like to bring forward with engineering systems is the idea of unintended consequences. Is that sometimes when we create something, invent something, put a system in place, is that we just haven't quite understood how it all works, and we haven't broadened our mind enough to consider all the parts and pieces. So sometimes we end up with really unexpected effects, and in the past, maybe we couldn't blame these engineers, the people who design these systems. For instance, would we be expected to blame the inventor of automobiles for our current climate crisis? It would be very immodest for that person to imagine his invention would become so prolific that it would, cause a significant change in climate. But now, in the future, we can start to think a little more holistically, and there's still problems where we think we've got it figured out, we've presented a solution, and it just isn't going very well, and has consequences that we're not intending. For instance, let's consider electric cars. Electric cars, like green, perfect, doing great, versus their dirty internal combustion, proponents. But the thing is that how do electric cars get their energy? How do they go forward and do that? Increasingly that's a complex question, but for the majority of time and in the majority of places, the answer can be generalized to be fossil fuels in the form of coal from coal-fired power plants. And when we take the worst case of coal-fired power plants that don't have clean emissions systems, the electricity that's being generated to power the car and all of the transmission losses and all of that can result in more carbon dioxide emissions than its internal combustion opponent. So it's very unexpected that an electric car could be more polluting than a gas car, but they can. It's just important, all of the parts of the system. We didn't expand our boundaries enough. So system boundaries are one of the important ideas when we're thinking about evaluating an engineering system. We need to know how deep or how wide are we thinking. Now, the key with engineering systems is that when we're rethinking an engineering system, we don't get just a single view. We get what they've described as a helicopter view, but what I'm going to describe as the Google Maps view. So in their explanation, we have a helicopter, and a helicopter can fly incredibly close to something and take a real good look, and they can also fly very high and just zoom out and see everything that we have around it. And a helicopter, similarly, we can evaluate things from different angles as well as from different levels of evaluation. Like evaluating it from a social perspective versus evaluating it from a technical perspective. We can think of this as changing the lenses. We have red, green, and blue receptors in our eyes, so we can imagine a red, green, and blue visor. Let's separate out the parts and let's use the way that we think about things a little differently. So but maybe a little bit more contextually, we can talk about Google Maps. With Google Maps, we can zoom into it's my house, there's my car parked in my driveway, to zooming all the way out to, wow, here's the whole world. I can see everything. Everything that humanity is, 99% of it at least, excluding the ones in space, is right here. And then when we think about considering it from different angles, we can think about different map layers. So we have, for instance, satellite view. These are the actual images of what we're seeing on Earth. And we can also consider it from a, topographical view. So like, what is the height and the elevation differences? Like, that was very important for navigating in the past. Or we could consider it from the perspective of roads. That's how we navigate now. So there's all these different layers that we can use to evaluate a system. So there are several aspects of the evaluation that they cover. There's specifically 4 fundamental perspectives that we might consider when we're looking at an engineering system: scale, function, structure, and temporality. That's going to be what we cover today. So in scope and scale, it's about zooming in or zooming out and seeing, okay, what are our system boundaries? Like, what are we going to consider in, and what are we going to consider out? What is within, what is without, and how are they related? We may have to change our system scope and our system boundaries as we go along, but considering where we're currently looking from is what you need to think about when you're rethinking for an engineering system. And then the function, what's the purpose? Like, what does this do? And then there's the structure. So how is this all organized? Like, we could have set it up in a lot of different ways. So why is it structured the way it's structured, and specifically, what way is it structured? And then there's temporality, which we've had a lot of difficulty dealing with in systems in the past, is that how does this change over time? What's the evolution process? And we can look at that in 3 different areas. We can look at, the general operating, like how does the function operate temporarily? Like, how long does it take to bring a box from the shipping organization to the person it's being shipped to? And then we can think about like small processes, like how long does it take that box to slide down the ramp from in one of the assembly lines in the factory. And then we can think about it overall, in this system of delivering things. What do we do with those boxes, and what happens when all of those boxes pile up? Or is this a continuous process that's recycling? We're not sure. And then we need to consider complex causality when we're looking at engineering systems. So sometimes we think of it being A causes B, B causes C, C causes D. But that's not often how it works in the real world. Oftentimes, there's an action-reaction pair, just like in physics. So I do something, and then something affects me the same way. Finally, we need to consider society in each of these systems of evaluation. Not only should we consider the technical aspects of it, we should also consider the societal aspects of it on each layer of evaluation. So there we have it. That's Chapter 3 of Engineering Systems, Rethinking About Systems. Bye.